All happy. It's Friday. That's a good thing. Although I believe some of you will be working tomorrow. Are most of you working tomorrow? No, you're off tomorrow. Good stuff.
Yeah.
Get some time off. Lots of time for revision. Nah. Enjoy your weekends off, guys. Make sure you get some time off. Right, so this seems to be getting most people in there. Okay, right, let's find my PowerPoint. Because I've got lots open at the moment. So we should be on. Where have I put it? Where have I put it? Put two. So. That's probably a bit small on your screen, to be honest. It's what is in your book as well, and you probably have it in book. I think it's in book 1. You guys got it in the old book. We've put it to the end of book 2 now. But we'll just go through the abbreviations to give you an idea what they are. Might do just for a bit of fun. Let's just change this a little bit. Swirl with it. Just before everybody sees it. There we go. Getting some of them. Right. Yeah, what I'll do, I'll go through the abbreviations. As I say, we tend to speak in abbreviations a lot of the time. Some of these you'll have come across in the book. Some of these we won't have spoken about as such yet, but it gives you an idea of the sort of abbreviations and acronyms that you might come across. So, as I say, if you get told to go and change or whatever it is, you might understand what the abbreviation is. So we'll just start from the top. Let's make sure we've got everything in classroom now. Thereabouts anyway. Okay, from the top, the first one I've got here is ACOC. So what would that be? What would an ACOC stand for? Anybody? Yeah, air-cooled oil cooler, just the same as an FCOC, except it's a fuel-cooled oil cooler. So some abbreviations can be the same as well. Next one down, we've got ADC.
Air data computer.
Air data computer, yeah. That's where you input all the information to set your see motorbikes in the background. AGB. This is where you might fit your fuel pumps, your generators, your starter motors, that sort of thing. What's a big bit of metal that spins your engine?
Accessory gearbox, sir.
Yeah, good. Accessory gearbox. We're looking at FedEx systems. We've got this ARINC or ARINC. Basically, do the communications with the FedEx. Anybody think what that could be?
Aircraft.
Aeronautical. No.
Yeah,
Aeronautical radioing.
Yeah, that's it. Yeah, basically communications for the FedEx. Good. Not mentioned this one really, although we do mention the system. It's just abbreviation to ATTCS.
Automatic takeoff thrust control system.
Yeah, good. AVV.
Air vent valve.
Air vent valve, good. And very similar, we've got ASVV. What do you think the S and the AVV could stand for? If an air vent valve is mechanical, an ASVV might be a
Air solenoid vent valve.
Yeah, electrically operated one. Yeah. I've not mentioned this, but you might know it from electrics.
Yes.
BIT.
Built in test.
Yeah, good. Sometimes it's called BITE, as in BITE.
BITE. Yeah.
Yeah, built-in test equipment.
Equipment.
Yeah, a lot of equipment nowadays in aircraft are self-bite capable. They will self-test themselves. And certainly with FADEC, they'll do inbuilt test themselves. This one, yeah, we're not really mentioning this one, so don't worry too much about it. But it's compressor, acceleration, bleed control, just different abbreviations. We don't need to ask them as such. Just some abbreviations you might come across. And then the next one will be compressor, acceleration, bleed control valve. So the late arrivers, the same people. CAS, you remember this from Module 8? Yeah, calibrated airspeed, good. CDP?
Compressor variable geometry.
Oh yes, that's the next one down, geometry. The one up from that, CDP. Think of it as P3.
Compressor discharge pressure.
Yeah, vessel delivery pressure, discharge pressure, yeah. Bit of a weird one, this one. EGME.
Diethylene glycomethylene ether.
Yeah, it's an easy one to say this time of morning. Yes, it's to do with cleaning. You can use it as a cleaning fluid as well. ECS. Well, ECS can stand for lots of things.
Yeah, engine control system.
Engine control system, nice and basic. Yeah.
Environment control system.
Yeah. You'll find a lot of abbreviations like PRV. That can mean lots of things. Which one we got now? Then that one. ICAS. Yeah, you'll know ICAS.
Engine indicated and crew alerting system.
Yeah. EIS.
Engine indication system.
Yeah, and hopefully we should all know what FADEC is.
Yeah, of course, fully authoritative digital engine control system.
And stuff. And we definitely know what FCOC is.
Oil, yeah.
FTNU, that's the one we're looking at with the LVDT and LVIT and all that good stuff.
Fuel metering unit.
Yeah, unit. And FSII in the fuel.
De-icing.
Ice
Inhibitors.
Inhibitor, yeah, ice inhibitor, good. GI, that's not an American soldier. What is it?
Ground idle.
Ground idle, yeah. HP, nice and easy.
high pressure.
High pressure, HPC.
High pressure compressor.
Yeah, we've got easy road now. HPT.
High pressure turbine.
IGN.
Ignition.
Yeah, IGV.
Inlet guide.
Good stuff. And give me 2 seconds, I'll get on to my next bit. Okay. Just do this one before I go. The next one ready? Right, next one. Again, from your Module 8 and that sort of thing. ISA or ISA.
International Standard Atmosphere.
Yeah, good. ITT. Again, apologies, a bit small on the screen here. I'll try and get it.
Means turbine temperature.
Yeah. LP.
Low pressure.
Nice and easy, yeah. LPT. Yeah, good. LSOV.
Latching shutter valve.
Good. LVDT. Yeah. Just going to change this a bit. I'll do it like that as we go down. Okay, next one, LVIT. You're right, it's something.
Induction.
Yeah, induction, transducer. MCL, you probably not had this one, but you will have, because we've done the thrust modes. So we've done the thrust mode. So M will be maximum. I'll give you a clue there. Maximum.
Climb.
C. Yeah, maximum climb. Yeah. And then we'll have MC R.
Maximum.
Maximum climb. I'll just move that down. Sorry. Maximum climb. Yeah. And then we've got MCR.
Maximum cruise.
Maximum cruise. Yeah. MCT.
Maximum continuous.
Good. MMV.
Main metering valve.
And MN.
Mach number.
Speed. Yeah. Mach number, N for speed, so it's a nice one to remember there, yeah. MTO.
Maximum.
Max takeoff. N1.
Fan speed.
Yeah, which would be LP speed, yeah, or fan speed, yeah. N2. HP, good. And then we've got NTO, again, to do with thrust modes.
Normal takeoff.
Yeah, normal takeoff. And this might get you though. OEI. It's not really in the notes as such. Again, it's just some of the ones. If you get it, well done.
What one engine
Inoperative, yeah. It's a fault diagnosis. P2.5. So annotations of engine.
High pressure compressor.
Yeah, which one? Which part?
Inlet.
Inlet pressure, yeah, good. On the 5th stage, yeah. Okay, PDSV. Yeah.
Pressure drop spill valve.
Yeah, pressure drop spill valve. Okay, PMA. Think electrical power.
Electrical power for the F deck, permanent magnet alternator.
So I'm good. For a bonus point, when does that activate? At what speed or what RPM or percentage of RPM?
50%.
50%, good man. Good. See, it's all coming together, isn't it? Okay. RMS, again, that's to do with electrical side of things. Certain, sorry, PRV, sorry. Do PRV first. Again, PRV can mean lots of things.
Pressure rising valve.
Yeah, it could be pressure rising valve, pressure regulating valve, pressure reducing valve. It could be lots of things. RMS, again, to do with electrical side of things.
Root mean square.
Yeah. RPM, nice and easy. Revolutions per minute, yeah. RTD.
Resistance temperature device.
Yeah, whoop, almost there. T2.5.
High pressure compressor.
Yeah, and with temperature, yeah, 5th stage.
Yeah, in first.
Yeah. TL.
Throttle lever.
Throttle lever, TLA.
Angle, throttle lever angle.
Yeah. And T/M. A bit of a weird one.
Torque meter.
Torque motor, yeah. And V/L. Again, like vapor liquid, yeah. And the last one, WF. Beautiful, yeah, good. Good stuff. Okay, get rid of those ones. Just to show you these ones again. All good. So again, that's just a little example of potential abbreviation coming. You come across loads more than that. Okay, there's certainly loads more than that to come across. All right. Okay, so that covers the end of part 2. That was just the last bit. Rather than go through that last night, everybody would be falling asleep anyway. Okay. What you would happen now is in your new books, hopefully getting soon, pages 135 to 140, we've got some questions. So what I'll do, I'll run through some of those, and then I'll put some up on a PowerPoint for you as well, some different ones. So let's this, sure everybody's in. Yeah, okay. So I'll just pick some at random. I say in your new books you'll have 5 pages of questions, and what I might do is I will send all the questions that are in the new books to you now, well, to Sanjeev to give you, just in case you don't get the books in time. Plus, it gives you some the questions separate from the books to go through as well. So I'll do that today. I'll email them at break time or lunchtime at the latest. So all the new questions in the book, I'll give you on separate sheets, and I'll give some good revision as well. The questions tend to follow in order of the book. So you just have to read through the books. If you don't know it, find a page and it should tell you the answer there. So they should be pretty much in order as they go through the book. Okay. So we'll say I've got split into separations. We've got fuel questions, lubrication questions, engineer questions, engine drain questions, ACC questions, engine starting questions, fire and protection questions, and so on. So there's quite a lot of questions there just to help you revise. So I will do that today. I'll send Sanjeev those questions separately from the books, and that'll help you with your revision. So I'll start with the fuel section, and I'll pick some questions at random, and then I'll put you on to the PowerPoint one. So let's look. Okay, I'll start with question number 4 here. What is the freezing point of jet A1? What do you think that is? What's the freezing point of jet A1?
Negative 47 degrees Celsius.
Good, yeah, negative 47. Number 7, what sort of temperature ranges would we encounter our good friend Cladosporin resinae, nice fungus? What sort of temperatures are we looking at?
25.
Yeah, sort of warm, moist.
25, 35.
Okay. What is the purpose of the LP cock?
Isolate.
Isolate, yeah. So when can we use it?
On ground engineers.
Say again, sorry?
During maintenance.
During maintenance.
And what else? So we can isolate for maintenance. Oh, thank you. Emergency, yeah?
In emergency cases.
What's the purpose of a fuel flow meter?
To indicate flight cockpit.
Yeah, we got an indication how much fuel we're using. Yeah, we calculate how much we've got. Have we got enough fuel to get where we're going? Okay. How is fuel pressure generated in a fuel system?
Fuel pump.
Yes, the fuel pump provides the flow. It doesn't provide the pressure. It provides the flow, and then your flow is your restriction to flow. Pressure is restriction to flow, which is through your pipes, your components, and all that sort of thing. Okay, good. My favourite one. Explain how a kinetic knife valve works in your own words.
How to but
So kinetic knife valve. Or explain if you tell me the positions of the kinetic knife valve. That makes it easier.
yeah, if knife is down,
Yeah,
valve is open,
yeah,
and if knife is up, then valve is closed.
yeah, good. So with reference to servo pressure, what's servo pressure doing in those two positions?
If our pressure reduce,
Restricting the speed of the pump.
Yeah,
Yes.
so we're cutting the fuel stream. So if we're cutting the fuel stream, we're bleeding. So if we're bleeding, we're reducing pressure. So servo pressure must also be reducing, yeah, or decreasing. And likewise, if the knife is out, well, we're not cutting the fuel stream, so there's no bleeding of the fuel. That means pressure must be increasing, or servo pressure increasing. Good. All right. Let's see. Let's pick another good one for you. Let's do. Oh yeah. Okay. What would happen if the diaphragm in the governor of the fuel pump failed?
There will be a gap.
So initially, yeah, pressure will keep increasing, but because, like what I said, there's a gap. Where's the gap?
Between
Engine RPM increases.
It will increase initially, yeah. So then the pressure in the pump will be able to squeeze through the gap in the half ball servo valve. That will then move the servo valve off, which allow the pressure to bleed away for a little bit. But underneath that servo valve that rocks like that, there's a little spring that once the pressure gets less or not small enough, that spring will actually push the ball valve back on again. And it'll be a continue on, off sort of scenario, and you get that hunting effect of it going up and down, yeah? But better that than blowing it up, okay? So good. All right. Let's see. We'll leave that one for the moment. Okay. Yeah. What do we have in our fuel system that can carry out adjustments to the fuel system due to atmospheric pressure and density changes? So what's going to automatically change our fuel supply through atmospheric pressure and density changes? Again, stick with the fuel pump diagrams. So what's going to spill fuel or not spill fuel off? Which component in the fuel system will automatically adjust for that? Think of your diagrams. You've got a fuel pump, and you've got this other diagram, another diagram, and another diagram. 4 diagrams to think of. One of those diagrams will adjust fuel automatically, mechanically, because of altitude changes and density changes and temperature changes.
No, atmospheric sensitive fuel control.
Yeah, so what part? What part in that?
Evacuated capsule.
Yeah, that's the one. Good. Yeah, the evacuated capsule, also known as an anaerobic capsule. Yeah. So as it goes up in altitude, less pressure, it's going to expand. As it comes down in altitude, it's going to contract. And likewise, temperature. You keep it flying straight and level. But if you come across a pocket of maybe colder, dense air from a warm environment, yes, that will contract and that will increase fuel as well. So it changes for pressure and temperature. And for a bonus one, which one does the RAM ratio or RAM effect?
Intake air pressure, P1.
And what's the annotations for those 2 capsules? What's the annotation for the anaerobic capsule? P what?
P0.
P0, good. And the other one?
P1.
P1, which is for forward speed of the aircraft. Good. See, it's all coming together. Okay, what's the purpose of the pressure drop control system? What's it sensing? Clearly, it's a pressure drop, but where is it sensing that pressure drop over? What's the main component it's sensing the pressure drop over?
Diaphragm.
Not the diaphragm, no. Think of upstream and downstream. So think of upstream of some component. What's the main component that provides us fuel, or selects fuel, should say? And you probably find the pilot is attached to it.
Spill valve.
Spill valve. How do we select fuel flow? Pilot has to move this.
Spring.
More than a spring. What's the main lever in the cockpit?
Throttle.
Yeah, throttle. So we're sensing the pressure upstream of the throttle between the pump and the throttle, and we're also sensing the pressure after the throttle to the burners. So the pressure drop control. So the pressure drop control is sensing the pressure before the throttle and the pressure after the throttle. And depending what's happened between the two of them, you mentioned the spring. I know what you mean by the spring. The spring will move down or up accordingly, depending on the pressure control. So let's say, for example, we sensed a pressure drop upstream. So that means in the high pressure system itself, we've opened the gate or opened the throttle. So a little bit of pressure's dropped down. That spring will take over, push the valve up. That's attached to your spill valve. Spill valve is moving up, which will close. That will block off servo pressure. So servo pressure will increase. If servo pressure increases, your pump output increases. Yeah. And likewise, if you bring the throttle back, well, you're closing off the space for the fuel to flow, so you'll get a back pressure. So this time, the pressure will be felt on top of the spring, which will move the spring down. Again, it's attached to the valve, which will move the valve down, which will open the spill valve, which will decrease servo pressure, therefore decrease pump output. Okay, and that's your pressure drop control, depending what's happening to the throttle position. Okay. What is control creep?
The vibration on the engine or airframe.
Yeah, and especially on turboprops and propeller aircraft, yeah, you get a lot of vibration. So potentially the throttles can start to vibrate down. So we've got the dampers on there. Can just stop from vibrating, especially when you're doing performance checks, you're checking the gauges and all that good stuff. Two main purposes of auto throttle.
To maintain constant air speed for ILS.
Yeah.
And the constant rate during flare.
Constant, good man. Okay. What does the term control rigging refer to? When we do control rigging, what does that mean?
Whenever we do maintenance.
Yeah, specifically to control. So what does that mean?
Yeah. We have to put the setting as
expand a bit more.
Yet we have to achieve the basic setting after the maintenance of any control.
Yeah. Yeah, get me going now. Yeah, it's if you've disconnected any control from the engine, as you quite said, we've got to set it up to specific settings, either adjusting the length or the radius, yeah, to adjust it. And it must be duplicate checks because it's very, very crucial. And what do we always set first? Do we set the engine maximum stop or the throttle maximum stop first? Or what should ensure always hits first? Is it the engine maximum stop first or the throttle in the cockpit stop first?
Is engine?
Yeah, always the engine. We always make sure the engine, when you move that lever in the cockpit forward, the maximum throttle stop on the engine should always hit first. And there will always be about a little gap in the throttle control, which we call the throttle bounce. So we hit maximum, we get a little bounce, yeah? That's what's called throttle bounce. That's ensuring that we've got full contact with the maximum stop in the engine. So that gives confidence to the pilot that yes, he is attaining full throttle position once you've set it all up. And I said before, you must have a duplicate check to ensure it is set up correctly. With reference to throttle levers, what do we mean by stagger checks? Yeah, all the levers have to be in line with a certain amount of tolerance. Yeah, it might be 1 or 2 millimeters. Okay, so if we've got 4 engines, okay, we put them side on. We don't want to see one engine like that, or all engines off place. We want to make sure all the levers are in pretty much in line. Yeah. So by changing, would it be the radius or would it be changing the length to make sure they're all in line? 50-50. So we change the radius or we change the length to move the position of the throttle lever. To make it
position, we have to change the length.
Yeah, that's right. Because you have set the range, how much it moves, but we need to select where that position is to make sure the lever is in line with the rest of them. Good. All right, what is breakout and pull-off checks? What's breakout and pull-off checks?
Is the check the throttle, that how much pressure we need to move the throttle?
Yeah, that's right, yeah. And what bit of equipment do we use to check that? You might use it to go fishing.
Throttle servometer?
No, just a good old spring balance, yeah? Just a bit with a hook, and we put it on the throttle, we pull it until the throttle starts to move, then we read off the reading on the meter, and what was the figures? What was the force required, or minimum sort of forces we're looking at?
1.5 and 4.5 lpf.
Pounds feet, yeah, good. Good. Okay. All right. Leave that one. What do we mean by a closed loop circuit when we speak about FADEC? What does that mean?
Redundant?
Yeah, it's redundant. It means it's failure tolerant. Yeah, that's good. But what else about it? Is it one way or two way?
Is two-way.
Yeah. So what do we call that two-way information?
Yeah.
It's a name for that. Well, sorry, we said that. Yeah. So it's a closed loop circuit, isn't it? Yeah. We send information out, and it gets information back in from various sensors. It could be the TLA, it could be N1, it could be EPR, it could be EGT, lots and lots of things. Yeah, good. How many FADECs are normally fitted to each engine?
Two.
Two, yeah. What are discrete signals, and describe what they do? So give me an example of the two types of discrete signals, and give me an example of each one.
It's cockpit or aircraft?
Yeah. Give me an example of each one of those.
In cockpit, we can have anti-icing off and on.
Yeah, good. Yeah.
Ignition on and off. Engine start stop.
Yeah.
All the switch moved by human beings.
Yeah.
And
Page number.
And for
Yeah.
aircraft discrete, that is WOW.
Yeah, weight on wheel switch, yeah. So again,
landing on.
Yeah, so one is in the cockpit by the human, the person actually moving the switch yourself.
Aircraft itself.
Yeah, it's a micro switch. It's mechanically moved. Physically, we can't lean out the cockpit and switch it off. Yeah, it's all done by the aircraft. Good. How many power supplies are there to the FADEC?
Two.
Yeah, your standard DC supply, and then when the PMA kicks in, 50%, we'll get the alternate on there. Okay. What are the 4 thrust rating modes?
Is maximum takeoff, maximum continuous, and climb, and maximum cruise.
Good. What's the percentages for each of those?
100% of N1, 186 and percent 76 and 70% N1.
Good man, thank you. Okay. Leave those ones for later. Right, okay, move on to some oil questions. Time going, it's 10 o'clock, good. Okay, give me some requirements that an engine lubricating must have. Lubricating system, should say.
First of all, cooling, lubricate, and prevent corrosion.
Yeah, all good stuff. Yeah, not too bad.
Resistance to oxidation.
Yeah, oxidation. Yeah, now with oxidation, what temperature would that happen at? What temperature would oxidation of the oil happen at, or would occur?
It's a high temperature.
Yeah. If I said to you 104, 114, or 124 degrees?
$104.
Oh, no.
120.
100 what?
Somebody is saying 20.
Yeah, 124 degrees. Yeah, 124 degrees. That's when basically cook the oil. The molecules in the gas will, the oil will expand. Basically cook it, make it like a treacly, sticky oil. Good. All right. What are the 3 types of oil system that we've looked at in book 2? What's the 3 names?
The oil relief valve.
Yeah, pressure relief. Yeah.
And then full flow.
Full flow
and the total loss.
Hopefully you'll not be feeling like that when you do exam. That's okay. All right. Where in the oil system would you find the last chance filters?
Excuse me, once again.
Yeah.
What was the question?
Where in the oil system would you find the last chance filters? So where would you find those?
Scavenge filter.
It's not scavenge filter, no.
Yeah, before entering the bearing, that is pressure filter.
Yeah. No, high pressure filter is different. The last chance filter is after the high pressure filter, after the pump. It's just before the. It's quite simple. As I said, just before the bearings. Yeah, it's the last chance. The last chance of defense before the oil goes into the actual bearing. All right. What items in the oil system are there to help remove air from the oil? There's 2 things we spoke about. There's 2 components that help
from
the air.
line. It is centrifugal breather.
Yeah, centrifugal breather on the gearbox. Yeah.
Yeah, and from the tank there is.
Yeah.
From the tank we do have, what is it?
It's like a tray with very, very small holes in it.
Yeah, it's deaerator tray.
Deaerator, good. Yeah, the oil will sit in the tray and dribble through, and the air will, because it's hot, will stay above, and that will just sit in the tank or be vented off to atmosphere. Yeah, good. All right.
के भन्नुभयो सेन्ट्रिफ्युगल ब्रिदर अर्को
Okay. What type of bearing lubrication is commonly used in a gas turbine engine?
The squeeze film.
Say again?
Squeeze film.
Yeah, squeeze film, yeah. Ball bearings, that sort of thing, yeah. Right, how do we make sure we have bearing chamber sealing? So how do we make sure we keep the oil within the bearing? So you've got the oil pushed into bearing, but without something else, that oil will just go out to the front of the compressor or the back of the turbine. So what component, and with assistance of something else, keeps that oil in the bearing before it goes back to the tank again?
You mean the leakage?
Yeah, what stops the oil from leaking out the bearing to maybe the front of the compressor? What do we use? There's a couple of things we use. There's a type of seal, and there's something else we use to keep the oil in.
Air sealing.
Yeah, do you remember the type of seal it's called? Remember Greek? No, not multi-air.
Carbon pro seal.
Labrum seal, yeah, labrum seal. So it's like a zigzaggy type, abradable seal. So if a sort of rough bit in the top and a zigzaggy bit in the bottom, as the air pressure gets pushed in, because of the shape of there, it's like divergent, so it builds a bit of pressure. The oil tries to escape out, but because the air pressure is blowing it back in, and it maintains it to that point, then it'll stay within the bearing until the oil goes back to the tank again. So we call that a labyrinth seal or an abradable seal, supplied with air pressure tapped in from the compressor. The other one you're thinking about is this one. What type of seal is used when we need to maintain a pressure difference between two sections of an engine?
That is multi-air seal.
Yeah, that's a multi-air one. Good man. Multi-air seal. Good. All right. Well, I'll move on to air systems. I've only got 4 questions there. So which one will we give you? Okay. If we had an LP cooling overheat warning light appear in the cockpit, what might that be telling us? So we get LP cooling light comes on the cockpit. So what's potentially happened there? So LP cooling overheat warning light. It's come on the cockpit. Could be a lot of things, but give me an example of maybe something that's happened. What do you think maybe's happened there? We've got an LP, like basically a thermocouple in the LP cooling outlet duct, and it's been activated, it's gotten too hot. But if it's in the LP cooling duct, what's potentially increased the temperature in the LP cooling air? Could be a few things. We could have a fire, that's not very good. But what might else have happened? It's not a fire, but something else has happened. Could be lots of things. Just give me an example of what. Yeah, we've had an overheat, but what's made that overheat? What's made that cooling air become very hot? Because remember, the LP cooling air is separate from the other air.
Bleed air. Bleed air.
Say this again?
Bleed air. Bleed air.
Bleed air, yeah, bleed air, yeah. We potentially maybe have some bleed air. Yeah, it's come out. It's from the HP compressor, but it should be coming out. So that's one example. Yeah, other examples, you might have a crack in the turbine casing. The turbine casing might have cracked and the hot air is escaping. Maybe a hot air pipe within the turbine area. The hot section, the combustion can might have cracked open and it's got some gas, even a flame potentially coming out through the casing, which is all entering the LP side. So we have a little thermocouple in the cooling duct that lets us know, wait a minute, that air should not be getting that hot. We've got an escape of hot air from somewhere where it shouldn't be coming from. So you have to make some reactions there. Yeah, okay, good. Why is the engine compartment split into zones? Why is it split into zones? Yeah, just if you split into, if you don't have zones there, if you have a fire starting in one part of the engine outside it, then it'll spread very quickly. By having zones, we can control potential fires that may happen. You can put firewire, fire detectors, and that sort of thing in certain zones. And with that in zones, which zone is most likely to go on fire? Not the hottest one, which one's most likely to have a fire? Zone 1, good. Yeah, you got a gearbox, the fuel pumps, the hydraulic pumps, electrical components, all good stuff, metallic fires, and that sort of thing. Yeah, zone 3 is the hottest area, because that's where turbines and combustion is. Okay. All right, move on to engine drains. What is the purpose of a gland seal? And where would you find a gland seal?
To prevent the internal leakage.
Yeah, it's a seal that goes around the shaft of any shaft that's rotating from the engine. You can find gland seals on the small shafts inside fuel pumps, oil pumps, main shafts, the turbines, compressors, and that sort of thing. All right. Okay. Let's move on a little bit more and we'll see what we've got here. Okay. In accessory cooling and active clearance control, what type of material is used for the sliding valve in an air off-take? What's the type of material? Because of the high temperatures, what sort of type of material do we use for a sliding valve? Anybody remember? Starts with C, ends in N. Carbon.
Titanium. Carbon.
No, not titanium, unfortunately. Carbon, yeah. Carbon is a good lubricant, so the valve can move back and forward because of the high temperature. Remember, you've got high temperature in the air off-take, maybe 400 to 600 degrees. It's quite hot, so the carbon can take that heat and also self-lubricate, so it can move the slide valve back and forward. Okay, what is active clearance control? What's active? What commonly known as ACC, active clearance control.
The clearance of tip clearance of the blade.
Yeah, tip clearance, yeah, the compressor turbine blade. Good. How many clearance controls are there? So we've got ACC, that's one. What's the other one? Other four.
RCC.
RACC, and then we've got HP and LP ACC as well, yeah? Now, with the RACC, the rotor ACC, that just does the turbine sides and it supplies air to the pipes to go around the turbine casing, expand and contract the turbine casings, yeah? And that sort of thing. It's all good. Okay, how are we doing for time? They're not too bad. I'll do a few more questions on starting systems and we'll go for a quick break. Okay, what is meant by the term self-sustaining with reference to a gas turbine engine start?
The engine speed from which engine will accelerate to idle RPM.
Yeah, it's self-sustaining. It doesn't need the starter circuit anymore, so we can get rid of the starter circuit. It's now looking after itself. Yeah, good. What do you mean by the term thermal shock?
The sudden change of temperature while starting the engine.
Yeah, that's the most dangerous point of an engine is during engine start. You've got a big, well, it depends the size of the engine, obviously, maybe a 2-ton big bit of coal, bit of metal that's now going to be spin very fast and potentially get up to about 2,000 degrees inside it, from maybe 8 degrees here in Scotland up to about 2,000 within a space of maybe 20 odd seconds. Okay, so thermal shock, one of the most dangerous points for an aircraft engine's life is during startup. So we get thermal shock. And likewise, when we use bypass air or tapped air for the compressor to the turbines, we can't use normal air because that'd be too cold. Again, that could cause thermal shock. What is meant by a hung start? A hung start. Anybody remember?
You mean a hung start? A hung start?
A hung start, yeah, H-U-N-G, hung.
Where
Engine is still rotating.
Right.
Say again?
Engine is still rotating, but it fails to accelerate.
Accelerate.
That's the one, good man, yeah. We're rotating, we're sort of getting there. We might have had the fuel in, but it's rotating, but it's not getting any faster. Either it could be we're not getting enough fuel, or we get a stall, or we forgot to open the throttle. So it could be something daft as that. You've actually been watching the gauges and you go, why is it not going up in temperature? Oops, forgot to open the throttle. Be aware of that. That does happen quite a lot, so just watch out for that. But it could be a technical fault. and it just will not accelerate. You can open the throttle, no, it's not having it. It's just not having it. That could be FADET problems, it could be fuel flow problems, it could be lots of things. Again, you'll start with the basics, you go through your maintenance manual, and you'll figure out, see what's gone wrong. Okay, what is the main problem with isopropyl nitrate starter systems? What's the main problem with it? And for a bonus point, how many starts can you get with an isopropyl or IPN starter system?
3.
Yeah, 3, good. But what's the main, I would say disadvantage, but certainly a main problem with it? What do we class that fuel as?
Flammable.
Say again?
Highly flammable.
It's dangerous and it gives the skin problem.
Yeah, and if you get covered in it, you'll go on fire and stay on fire. Okay, it's classed as a monofuel, very, very volatile type chemical. It's monofuel because it doesn't need oxygen, it provides its own oxygen. So it's self-burning. The only way you can put it out is to cover it and let it burn itself out. Okay, so just stay away from it. Again, military type aircraft have it. You won't see it on commercial aircraft, but just in case you've maybe had a visitor from a military airfield that's maybe diverted, like an F-16 fighter aircraft, which has this type of fuel, just stay away from it, okay? Especially when they're going for a start. You can't see it, you smell it, it'll just hang low on the ground, and if you happen to walk into it, it'll stick to you. And if it goes on fire, well, that's it, you're toast. Okay, we don't want that. Dangerous stuff indeed. I've never had to work on it, frankly. I've worked on lots of military aircraft, but luckily never had to work on that stuff. Nasty stuff, but it does the job. It does start it. Okay. From what sources does the low pressure air starter get its air from? So we can get air from various places for the air starter. Where does it get its air from?
From APU.
No, it's big enough from atmosphere. Yeah, APU, yeah, little jet
Ground
engine.
supply.
Ground supply and engine, from the engine which is already running.
Good, yeah. So another engine, we can give air from another engine, supply it to the other one. APU, which is in the back of the tailplane for most commercial aircraft, or an external ground trolley that has a small jet engine on it, and that also supplies air to the air start as well. So a few different sources there as well. Good. Okay, that's a good point. We'll go for a break now. Some more questions for the moment. After break, we'll finish off some of those questions, and then I'll put other questions on PowerPoint. Yeah?
It will disengage.
Yeah, because of the hooks on it. It's the same sort of principle. You'll find a Sprag clutch in your, like a push bike. A push bike has the same setup. When you're pedaling, when you crank at the front, you've got a Sprag clutch on your sprockets at the back of the wheel on your push bike. If you start back pedaling, you'll hear the sort of sound, and that's the same effect. It's like a Sprag clutch as well. So yeah, the gas turbine, if the engine gets fast enough, it will be too fast compared to the clutch. It'll go faster than that. That will just bounce over itself, and eventually the circuit will disengage and actually move out of the way as well. Good. All right. When working on an ignition system, what precautions should you take? So let's say you're going to replace an igniter. What would you do first?
Fuse must be removed.
First thing is the CB must be tripped.
Yeah, remove power, trip a circuit breaker, yeah. Then what else will you do?
Then we have to allow at least 1 minute.
Yeah, for which type of igniter? Remember, there's two types of igniters.
Yeah,
Two different.
it is for the surface spark.
Yeah, surface spark, surface gap. Yeah, surface gap igniter. At least 1 minute. Good. So you disconnect. Which lead did you disconnect before you wait for 1 minute?
HT.
You've just died. You've done the funky chicken dance. You're jumping about all the place, shaking away, doing a fancy dance. Everybody's laughing. No, not laughing at you. You'll have removed the power first, which is fine, but there's still potential for power in that circuit. If you remove the HT lead first, you might get about 25,000 volts initially going through you. You'll become the earth. So it's not that one. So the other lead, which is the
Low tension, yeah.
low tension. Just think low tension, low power. High tension, high power. Low tension, small lead. That's your voltage into your HIU, which could be 28 volt standard or possibly 115, depending on the system. So yeah, circuit breakers first, power supply isolated. You might have to put a tag on the circuit breaker to let people know that it's tripped. We call it placarded or tagged. Then disconnect your LT lead. Wait for at least 1 minute for a surface gap igniter, or how long for an air gap igniter?
Three minutes.
Yeah, 3 minutes. Yeah, it's a bit longer. And then once you've done that, basically, I would say disconnect your power, disconnect lead, go and get your tools ready to do it. By the time you've done that, that's probably 3 to 5 minutes anyway, you know, or go and have a cup of tea, like we do here. But then, yeah, once you've done that, go and disconnect your HT lead, and then you can work on the system safely. Okay, always give a bit more than long. I always give at least 5 minutes just to make sure. Okay, go and do something else, get some paperwork signed or whatever, or prep ready to do the job. Although it says a minimum of 1 minute, a bit longer is always better than too short. Okay, inside the HIU, there was 3 components we spoke about: the choke unit, the safety resistor, and the discharge resistor. What was the purpose of the safety resistor? What's the purpose of the safety resistor?
Enable the unit to discharge safely from the high tension lead.
Not that one, not the safety resistor. That's the other one. Yeah, it prevents firing. Yeah, good. That's exactly what we're looking for. If just in case you were to touch, say that's the HT lead, positive and negative, yeah? Put it there. And you touch, and you make a circuit, you become part of the circuit. Now, if for some bizarre reason somebody hadn't done the circuit breaker, had done the LT lead, and somebody pressed the start button, then potentially you can become a circuit. But if it senses there's a gap there, the safety resistor will sense that change in resistance. It will not allow the spark to happen. Okay, just in case. The discharge resistor, like I mentioned before, that is there to, once you disconnect your LT lead, it will discharge to earth the power stored in HIU within about 30 seconds. So that's why we give a minimum of 1 minute for a circuit and a minimum of 3 minutes for an air gap igniter. Okay. Safety first. Always, it doesn't matter what type of engine you're working on, it is power, circuit breakers, low tension lead first. Always the low tension lead before you even think about working on the igniter. Okay, it doesn't matter. Every engine is the same principle. They might look slightly different, slightly different colours, slightly different HIUs, etc. But they will. It's the same operating procedure. Safety, safety, safety. Okay, how many sparks are produced normally on the HIU per second? And how many joules is there? How much energy? Yeah. How much joules energy? Yeah, they're about 12, 14 thereabouts, yeah. And what is the spark rate per second of a FADEC controlled engine?
4 to 7 per second.
Yeah, 4 to 7, yeah. Needs a little bit less. It's only about 2 to 3 joules thereabouts. When would you switch to continuous ignition? What sort of conditions would you have continuous ignition on? Yes, again? Oh, yeah. Think of weather conditions. Okay, you may be flying in turbulent weather. As it says, you'd be flying through, you might switch continuous, just in case there's a chance of flame out, especially on takeoff. It could be a wet, slippery, snowy, slushy day, not like here, very similar to what's here in Scotland. So if there's a chance of flame out, you leave continuous, and even when the engine starts again, that ignition circuit will still continue to spark for at least 1 minute afterwards, even though the engine started, just as a precaution. Okay. Why are the HT leads shielded with the metal braiding around it? What's the purpose of having that metal braiding around the HT lead?
To protect it from the interference of electronic service.
Yeah, because you're producing a magnetic field. You've got electrical high voltage going through here that's going to produce a magnetic field. Well, that magnetic field could interrupt some cables and certain equipment in certain aircraft. So by shielding it, that prevents interference, and that shielding is grounded to earth as well. Okay, let's move on to fire detection and protection. All right. What are the main requirements of a fire detection system? The two main things. What should it be able to do? There's two main things a fire system should be able to do.
Indicate the fire first.
Indicate a fire, or not quite a fire, almost a fire, but not quite a fire. So it's got to distinguish between a fire and a, what else?
Component. Killer of the component.
Yeah, well, that's as well, yeah. But also an overheat. It's got to be able to distinguish between it. We don't want to set the fire bottles off just because it's got a little bit too warm, because this might be a little temporary overheat. So it's got to distinguish between an overheat and a actual fire. All right, how does a differential expansion switch work? Just a basic terminology or basic principle. So a differential thermal expansion switch. So what happens there? What makes that switch make a circuit?
Two dissimilar matter.
Yeah, difference. Yeah, I can give you that one. The expansion one, that's its same sort of thing. You've got a silver barrel, so when it heats up, it expands, right? And you've got two contacts in the middle. That when the barrel expands, it brings the contacts down. That'll make a circuit. Okay. In a single firewire system, what do we call the outer casing of the firewire? What's the name of it? I always think it sounds like a rap star. What's the silver negative casing round the firewire? You've got the outer casing, which is negative. You've got the center core, which is positive. So what do we call that outer casing? There's a name for it.
Dielectric.
Tube.
Inconel, yes, somebody said that. It sounds like a rap star. Here comes the Inconel. Okay, that's the negative side. The conductor through the middle is positive. Okay, now when there's just one conductor and the insulating material and the core, what is that type of firewire called? It starts with an F.
Fenwal.
Fenwal, yeah, good. Fenwal has a single conductor, and then the same firewire with two conductors is called what type?
Kiddie.
Kiddie, yeah. We've got a positive and the negative conductors going through it. Now, surrounding either type, we've got an insulating material. What was the insulating material called?
Dielectric.
Dielectric or eutectic salts, yeah. So when it's in a dry, cold condition, it acts as an insulator. But when it gets too hot, it melts. Salt, like salt water is a very good conductor of electricity. So this eutectic salt material, when it melts together, it becomes like almost like a liquid. That becomes conductive. So then for the Fenwal one, the positive core and the negative core will make a circuit. And same for the Tourniquet one, the positive and negative cores, because eutectic salt is melted, that will also make a circuit as well, just two different types. All right. How does a liquid type detector work? Hang in there, don't worry, it's Friday. Don't start yawning now, you'll make me yawn. You'll see me, I can't see you yawning, I can hear you.
What is the question, sir?
How does a liquid type detector work? What's the basic principle with a liquid detector?
Work on the principle of a Bourdon tube.
Yeah, pretty much. Expansion of liquid. And what do we have in that tube? Just to calibrate it so it doesn't open too quick or expand too quick. What is fitted in there? So you've got the big hook, Bourdon tube, but what's in the tube? Apart from the liquid, there's something else in the tube to stop it expanding too quick. What do we call that little thing in there?
Restrictor.
Restrictor, yeah, restrictor. That's a calibrated restrictor, so it restricts the flow of the fluid as it expands, so it's not too quick. Because if it expands too quick, it could open that micro switch too quick and give us a false reading. It might just be an overheat. So it's calibrated to expand at a certain movement, so it slows it down a little bit. Okay. All right. What problems can we potentially have using an infrared system? What was the early problems we had with that one? So an infrared type system, the early problems were it could set the fire extinguishing system off just by doing what? Yeah, you open the door of the engine bay and that sometimes we set the fire system off. Not very good, is it? So the early problems were, yeah, it was too sensitive. So now they've gone into a slightly better system. What's the benefits of a digital fire detection system? It's very similar to the normal firewire. It looks the same, but it's now a digital version, so it does capacitive and resistive at the same time, but also
Good reliability.
Sorry?
Reliability and accuracy.
Yeah, I think we've got there, yeah. It's sealed, so there's less chance of getting moisture and debris and contamination there. And how long can we use it for? Yeah, unlimited service life, unless obviously it gets damaged. And another bonus is, if you cut it, will it work or will it not work? So say you have a break in the wire somewhere, will it work or will it not work? What do you think? So say I have to cut it, is that broken or will it still work, apart from the bit that's broken? Anybody? Yeah, it will still work. Even though it's broken, it still works. The side wire, so it's very, it's a very good.
Is
right.
Excuse me, 1 second, please. The answer. Why does it work even if it is breakdown?
Because it's got it's resistive and it's a mixture of both types of firewire. It's resistive and capacitive. So because of the loop that's going round in it, the A and B, there's always one circuit working. So it will sense an open circuit or a short circuit, and it will still work. Okay, even if you break it, apart from that bit that's broken, yeah, it will still sense a certain area. So although it's a continuous loop, if you do break it halfway down, it will still sense a heat in that broken part behind and above it, okay? Because the capacitance and resistance type it's in there. So it's a basic circuit, basic system, but very resistive to problems. Okay, what checks must be carried out on extinguisher before you fit it?
Weight check.
Yeah, we do a weight check. Yeah, check it. That'll be checked maybe once a year or twice a year, possibly. What else may you be looking for?
The type of distribution.
When somebody said pressure there, yeah. So checking the pressure gauge if there's a pressure gauge fitted. What else? Just normal sense. Just that. The date of when it was serviced. You've got the cartridge units on there. You need to check the cartridge units. That leads us on to the next question. How long or what is the life of a cartridge unit? Of the cartridge goes bang within a fire extinguisher. What is the life of one?
5 years life.
5 years shelf life. Then we take, yes,
2 years in life.
Yeah, 2 years in life, providing it's still within the 5 year point. So say, for example, that cartridge was serviced and made 4 years ago, you can still use it, but this time it will only have 1 year of in-use life left because there's only 1 year of the 5 year life left. Although we normally have 2 years in-use life, there's only 1 year left of it. So yes, you could use it, could do for a year, but it's got to be within the 5 year period. So as long as it's got within the 5 year period, it will have 2 years in use life. But again, as I say, if it's already been shelved for 4 years, then you've only got 1 year left out of it. Okay, even though it's got a 2 year in use life. So whichever is less. Okay. All right. Why do you have to be very careful when a halon type extinction has been used on an engine, especially the BTM? What is BTM extinction very nasty to or doesn't like touching? So BTM 1301, that methane, easy for me to say. 1301, halon 31, it's very corrosive on what type of material in the engine?
It's a semi-toxic.
Yes, toxic, yes, yeah, for the people, and BTM especially is very corrosive to titanium. BCF, again, toxic, so don't inhale it as well. But certainly BTM is a bit nastier. It can be very corrosive to titanium components within the engine. Okay. Okay, that's not too bad. Yeah, that's just a few questions. There's lots more. I'm not going to go through them all. I'll just have some of the basic ones there. As I say, I think we'll do at lunchtime. I'll send Sanjeev all these questions.
BTM is also very corrosive, sir.
Yeah, BTM very corrosive to titanium. So any part that's got titanium, it's very corrosive to it. And also yourself, so don't leave it in. BCF, BTM, you've got your halon, and they're both halon numbers. So what was BCF, halon? What was the number for that one?
901.
Yeah, and what was 1211, Halon 1211 is BCF, and for your BTM, your Halon number was
1300.
No, for
13.
BTM it was Halon 1301.
Yeah, 1301, 1301 for BTM, and BCF was 1211. Make a note of those ones, guys, because there's usually a question on one of those. They might say, what is the Halon number for BTM? Or Halon is also known as, or Halon 1211 is also known as BCF. Okay, and that sort of thing. Good, 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 good. Right. As I say, I will send those questions. Well, I'll email all those questions anyway, plus the rest of them. They are in the new book, so hopefully you'll get new books by. I was hoping to get them this weekend, but I don't know if you've got them yet. I will email Sanjeev to make sure you get these questions at least. If you don't get the books in time, you'll have the questions on time. And even if you get them together, it's good to have the questions separate from the book. It'll save you going back and forward in the book. Okay, you can write the answers beside them as you find them. All right. Righty-ho, right. So that's pretty much that part there. What I'm going to do now is, what time on there? We'll do a few questions on the PowerPoint. So some of the questions we'll have covered, some of the questions we haven't covered. So we'll have a little go through up to the next break point, and then we'll take it after lunch and we'll do a bit of a book 1 revision again. And then we'll see how we go. We'll do a little bit of book 3 just to get you the feel for it for next week. Okay, so on to the PowerPoint revision questions we've got set up for you. Question number 1. We've had this already, so it should be straightforward. Throttle lever breakout checks are a way of checking what?
Check throttle.
What do you think? What's the purpose of a breakout check?
Moving the spring.
So checking for the throttle lever.
Yeah, how much force it takes or is required to move the throttle forward and backwards.
1.5 and 4.5.
Yeah, you beat me to it. That was going to be the next question. So yeah, so we're looking at basically the force required to move the throttle lever. It's quite like I said, 1.5 pounds-feet to about 4.5 pounds-feet, thereabouts. Question 2, aircraft fuel is used primarily for combustion, obviously. Another requirement is also to do what? What can we use that fuel for?
Cooling purpose.
Fueling, yeah. What else?
Oil.
Yeah, lubrication. So to cool, lubricate fuel system components during standard operation. We can also use it. We used to use it on the military aircraft. We'd take a little bit, we'd drain some off on a rag, and we'd wipe all the hydraulic oil off the fuselage that was making a mess, because it's good at doing that as well. But don't do that. Don't get caught doing that. The fuel system icing inhibitor, or FSII, prevents what?
From icing.
What from icing? Is it fuel or the water?
Fuel. Water icing.
Yeah, it helps prevent the water from freezing zero, up to minus 46, 47. It also prevents the fuel from crystallizing, because the fuel viscosity will get denser and denser. So the fuel from waxing and potentially blocking components. But yeah, the icing inhibitor prevents the water from freezing, but also helps. Diesel is a very waxy fuel. When it's nice and normal temperature, it's nice and thin, obviously fluid, but as it gets thicker, it sort of gets very waxy, very condensed. I've said before, places like Canada and Alaska, very cold environments, you will sometimes see people that drive HGV lorries, they will actually put small fires underneath their fuel tanks. It looks a bit bizarre, but what they're doing, they're actually melting the fuel so it can be used for the engine because of extreme conditions. I have seen it here in Scotland many years ago. My dad used to be a lorry driver, and yeah, they used to light small fires underneath the fuel tanks just to melt the fuel. Okay, a bit bizarre looking, but it means to get the fuel to move. But otherwise, FSII additive also prevents the water from freezing. Instead of 0 degrees, down to about minus 47 instead. So more in line with the fuel, because remember, Jet A1 fuel freezes about minus 46. And normal operating conditions for an engine start are maximum about -40. Okay, very extreme conditions. Corrosion within a fuel system can be also helped or prevented or minimized by adding what else into the system? Anybody remember the names of these things we put into the fuel system?
Adding inhibitor.
Yeah, we'll have it in, not that's inhibitor, but we can put, maybe remember them, they're called strontium chromate tablets. They look like a pack. They look like a pack of sweeties, right? Don't eat them, but they look like a small packet. We can put them in a fuel tank, and certainly being a biker, I've seen some of my fellow bikers put a very similar substance into the fuel tank of a motorbike, and that helps prevent corrosion and rusting as well. And it does work. It actually does work very well. We got to show them on our train. I've never used them in the Air Force. Usually the fuel's got enough additives in it. We tend to keep the aircraft full all the time. If you keep the aircraft tank full of fuel, that helps prevent air getting in there, helps prevent corrosion. Number 5, the read vapor pressure of a Jet A1 fuel is. Now, it's not in your book anymore, but it's just a bit of background. Remember the pressure involved in that?
2 at the
Yeah, just a small amount of PSI, not much at all. 2 to 3 PSI. At standard sea level temperature, nicely corrected, and increases with temperature increase. Yeah. Just remember what read vapor pressure is. The pressure at which an aircraft fuel will ignite at a certain temperature. For 6, a gas turbine engine high pressure fuel system must do. In general, what must it do? Or provide?
supply fuel.
Supply fuel, yeah. That's cool. A bit more than that, though. Spray the fuel. Just sometimes.
Atomize the fuel.
Time. Sorry?
Atomize for combustion.
Atomize, yeah. Under all conditions, yeah, good. So provide sufficient fuel for startup. Yeah, got to do that. Allow for changes in app conditions and provide it all the time. It doesn't matter what the condition is, as long as it's flown in what it's been designed for. It can't just work some of the time. It's got to work all the time. Yeah. 7, aneroid capsules in a mechanical fuel control unit. Correct pump output for changes or correction in what conditions?
Change in altitude, temperature.
Yeah, good. Yeah, air density, altitude changes, and possibly temperature changes as well. Good. Also known as the evacuated capsule. Number 8, engine design speed limits are maintained by 2 basic systems. So where do you think, there's other systems we're going to cover in book 3, but 2 basic systems we've covered in the fuel system which controls pump output, okay? Maximum pump output. So if it gets too fast, too much pressure, what takes over? Governor, yeah, that's one of them. And what else?
Spring.
Solenoid.
No, not the spring. I know what you're thinking of. So I'll give you a clue. Something to do with electric.
Solenoid.
Solenoid, yeah. The amplifier, you've got the speed signal and the temperature. So if it gets too hot or the spill gets too fast, we have the speed amplifier, yeah. So the HP governor in your fuel pump and a solenoid operated LP speed limiter. So if the LP spill goes too fast, it will activate. And also if EGT is too much, it will also activate as well. Number 9, in a fuel-cooled oil cooler, FCOC, which should have the higher pressure, fuel or oil?
Fuel.
Oil.
Ooh.
Oil.
Oil?
Oil.
Oil? All agreed in oil? Anybody say fuel? Hopefully not. It's always the oil. We want the oil, we don't want it to, but if there's a break in the matrix, the little tubes, the oil will go into the fuel. That's okay. We can burn the fuel, we can burn the oil out of the exhaust. But if the fuel goes into the oil, Well, that goes to the bearings. That will change the viscosity of the oil, won't be as effective, so potentially go on fire and seize engine as well. So we don't mind the oil going to fuel. That's okay-ish, not ideal, but we don't want the fuel to go into oil. So oil pressure is always higher than fuel pressure. Now, which component in the oil system makes sure the oil is higher pressure than the fuel pressure?
Pressure maintaining valve, PMV.
Thank you very much. Yeah, pressure maintaining valve. Good. Okay, number 10, to increase fuel pump delivery, what must also increase first?
Servo pressure.
Servo pressure, yeah. Good. So servo pressure increases, output's going to decrease, yeah. It's going to move the piston along, increase the cam plate angle. That increases more fuel pulled in to push more fuel out. Good. So easy thing to remember, if servo pressure increases, delivery pump output increases. If servo pressure decreases, delivery pump output also decreases. So there we go. 11. A FADEC engine control system can be described as what type of system?
Or rated
Closed loop system.
Closed loop? Yes, I'm saying it. Yeah. A closed loop, and I'll say it's got two channels, A and B, fuel control system. Well, what will happen during typical
डिस्टर्ब आयो
धेरै डिस्टर्ब आइरहेछ यार हेरी तिम्रो माइकबाट.
Okay, so what will happen? A typical basic, just think of a start up an engine. Every time it starts up, what's going to happen basically? Don't think too deep in this one, just a basic operation. But every time the engine starts up.
Channel
two channels.
Alternate control.
Yeah, that's one. Yeah, sorry. Yeah, alternate control. Good. Channel A and channel B alternate control on each power up scene. So we only have one igniter firing. Channel A will operate first. One igniter, engine will shut down, and next time that engine starts up, channel B will take over and start an engine up, and then hand back to probably channel A. It just alternates the power. So remember, channel A is normally the one in control. Most of the time, channel B is sitting in the background, having a cup of tea, just keeping an eye on things, watching out for surges and any alter bits that channel A has forgotten to check. 13. Channels A and B of our FADEC are connected by what? What connects channel A and B on an engine? 4 letters. Give you a clue? That's a clue. If again, here's a clue. What shape am I making?
Cross.
Yeah.
Cross channel data link.
Yeah, that's the one. Good man. Cross-channel data link. So, yeah, cross-channel data link. So you can share, excuse me, share the engine data to the FADEC status. So each FADEC is looking at each FADEC through a cross-channel data link, as it sounds. 14. Typical inputs to a FADEC computer include, there's a few, but just think of the basic ones, the very first diagram. What sort of basic input does a FADEC look at?
Engine pressure ratio.
Yeah, EPR, yeah.
N1.
N1 and?
Fan speed.
Yeah, possibly. But what's the other main one?
Air data.
Yeah, it can do air data. Yeah, that's another one. And there's another one.
Cockpit discrete. Cockpit discrete.
Not so much the discretes. Yes, it does inputs from the cockpit discretes, but what's the main one in the cockpit?
Thrust angle.
Yeah, TLA, good. So what we're looking at there, yeah, you can have ADC, TLA, EPR, and N1, and yeah, ADC as well, obviously. So yeah, TLA, EPR, and N1 definitely, and also information as a reference from the air data. Okay, this one, go for another break. So FedEx systems are considered to be what? So we know what type of system they are. They're a closed loop dual channel circuit. But what is FedEx also considered to be?
Redundant.
Yeah, good. Redundant, therefore failure tolerant. So no, it's a self-contained system. It doesn't go wrong. Well, maybe it does. How do we know it goes wrong? Okay, so we do have to test it every so often, but it will download information. And some of the aircraft today, they actually as they fly over the aircraft, fly over the airport, they will download information to the computer system on the ground and tell the system what's wrong with itself. And then even print out job cards. Some of the aircraft do that. So actually, it doesn't let the pilot tell what's wrong, it actually downloads the information itself. So yeah, class is a fully redundant, therefore failure tolerant system. Okay. Okay, guys, let's go for another little break there. We'll come back and we'll finish off these questions. Okay. Question 15. FedEx systems considered to be fully redundant and therefore failure tolerant. We'll move on to the next one. 16. Active Claims Control, or ACC, is what? What is ACC?
The clearance between the tip of the blade for the compressor and the turbine blade.
Good. Yeah, controlled by FedEx, maintains optimum compressor and turbine blade tip clearances. Good. 17. If the temperature of a typical gas turbine engine oil reaches approximately 124 degrees C, what happens then?
Oxidation.
Yeah, oxidation, yeah. It may become oxidized, therefore altering viscosity, become thick and sticky and trickly. Not very good. No use. 18. Viscosity of a gas turbine engine oil must be
Low.
Yeah, in more general, you're quite right, what you said, but remain suitable throughout all engine operating ranges. Doesn't matter if it's a cold environment, a hot environment, that oil has got to be suitable. And same again, going back to cars and motorbikes, the oil you put in your car must be the right oil, suitable for your climates. Hence, you get your 530, your 1040, and those sort of. In a pressure relief valve lubrication system, the pressure relief valve does what?
Return the oil to the oil tank.
Yeah, a predetermined level, yeah. So when it gets to a certain level, limits the maximum oil pressure at high engine RPM set. So as the engine's getting faster, the flow from the pump is getting more. So if there's more flow, there'll be more pressure. More pressure could potentially damage the system. So the pressure relief valve is set to open at a set pressure setting within that system. So that's be a pressure relief valve type 1. In which lubrication system does a pressure filter have a differential pressure switch? So think of the two names and which one's got a differential pressure switch?
Full flow.
One which does not have pressure relief.
Yeah, it doesn't have pressure relief. It's got a metered spill back to tank. So the full flow one have a different differential pressure switch. If the pressure gets too low, again, it will switch a warning in the cockpit saying we've got a problem. 2, as well as providing lubrication, a gas turbine engine oil system should also do what? So apart from lubrication, what does the oil also do?
make the oil hotter. Sorry, make the
Cooling,
fuel
cooling,
hotter.
sir.
Yeah, it should be cooling. Yeah, it's going to get hot, but it's to cool components. What else does it do? So lubricate, cool, and
It will make the fuel hotter. Hot.
yes, it can warm up when the fuel cooled out. The cool, yeah, it can certainly warm the fuel. But what about inside the oil system itself? So we can lubricate,
Cooling.
cooling, and prevent.
Icing of the.
Not well. You can use hot oil in certain systems to help prevent. Actually, you wouldn't say wrong with that. But what is oil very good at preventing? But it's a car engine or
Corrosion.
corrosion. Yeah, good. Cool components and prevent corrosion, prevent rusting and all that good stuff.
Yeah, with option it will be better.
Yeah, that's right. What's the function of the oil system scavenge strainer? So what's the purpose of that one? So we've got the low pressure filter, we've got high pressure filter, we've got last chance filters, and we've also got an oil scavenge filter.
It return the fuel to the tank.
The oil.
Oil, sorry, oil. Yeah.
So yeah, it's on the return line. It's not a fine mesh, it's quite a coarse wire gauze type one. It's just in case something breaks down on the return back to the tank. Okay, it can help for diagnostic problems as well. Okay. To collect debris within the oil system that can be used to detect potential engine failures as well, as long as coincidentally with your magnetic chip detectors. What will the pump sizes be for the pressure and scavenge sides?
Bigger, and the pressure one is small.
Good, yeah, because they've got increased volume because of the heat of the oil. So the pressure side is a small capacity pump, and the scavenge side is a larger capacity pump. What flight deck indications may be provided by a gas turbine engine oil system? So what you might to see to make it keep an eye on?
Low pressure.
Yeah, low pressure. So you got pressure, yeah. What else?
Oil temperature, oil temperature.
Temperature of
yeah.
the oil.
Yeah. So what was that together? So you got pressure, temperature. Anything else? Okay. Yeah, oil temperature and pressure, and also to do with pressure, the bypass operation on FCOC as well. Yeah, just let us know what's going on there. And you have your differential pressure switch on the fuel flow system for low oil pressure. You can have a low oil pressure switch. You can have your pressure differential switch to give you a gauge pressure. Okay. Where in an oil system would you find a thread type filter? For this one earlier.
Pressure filter.
No, where would you find a thread type filter? You've got a pressure filter is a very narrow filter. You've got LP filter, a scavenge filter. There's also a thread type filter, very, very small, very, very fine mesh of wire. So where would you find that one? What do you think?
Dun, dun.
What's a thread type filter also known as? So if it's a thread type, it means we screw the filter in, yeah? A very small one, very small gauge of wire or mesh. So it's only going to pick up very, very, very small particles of debris. And it's called a thread type filter, but also known as a... Can you picture the diagram? Also known as a last chance filter. So where would you find that one?
In front of bearing.
entering the bearing.
Just before the bearing. So a thread type filter is also known as a last chance filter. So two names for the same thing. Yeah, that's why I put the name up there. So yeah, just before the bearings. Very, very small, very, very fine gauge, just before the bearings. And you can only access that when the engine gets removed from the engine and maybe goes back to an engine bay for strip down. You can't really access it normally. Okay, which type of bearing or bearings are the most common found in transmission assembly? So transmission assembly would be gearboxes. So what's the most common type of bearing?
Radial.
Radial, yeah. Radial bearings. For engine, gas turbine engine shafts, it's usually ball bearings, but for transmission, it's certainly used radial bearings. What type of bearing accepts both radial and axial, but only in one direction?
Angular contact.
Angular contact, yeah, angular contact bearing. So have an extra lip on one side. So one side will be open, one side of a lip, so it can only go one way. But both radial or centrifugal and along the axis as well. Squeeze film type bearing lubrication will do what, or will prevent?
Reduce vibration.
Vibration, yeah, by having that little film of oil between the housing that the bearing sits in, so a little gap there, the oil takes up the gap, allows for thermal expansion and contraction, and that helps prevent the bearing chattering, as we call it, within the housing. So it helps reduce vibration levels. What type of seal is used to maintain a pressure difference between two internal engine sections?
Multiple type. Multi-air.
Easy one. Yeah, multiple air seal. Yeah, but two different sections, so it's a multiple air seal. Or multi-air seal. Good. 31. During ground operations, cooling air will only be induced into the main engine compartment if or when so when can we have that on the ground? So if we're flying, we don't want to do that because we're flying, we've got nice cool air outside us. But on the ground, we can operate the system only when?
When in very high temperature?
Well, we will operate because high temperature, we need to operate, yeah. But what physically allows us to select the system, if that makes it easy, without giving you an answer? So it can't be operated in flying mode, but on the ground we can select it because what would allow us to be able to select it? What's that master switch called? There's a lot of things, this one. So even if we, sorry? When a lot of systems can only be operated on the ground only when this is activated. Yeah, the weight on wheel switch, yeah. So if selected in the flight deck, so you can actually switch it on and the weight on wheels is selected. Okay, so the weight on wheel switch, mega switch selected. Even if we select it in flight, it won't work because the weight on wheel switch hasn't engaged. So yeah, we might select in flight, it won't work. It's a safety thing. We don't take a tapping of air from a compressor when we're flying, when we've already taken too many tappings, because that can reduce thrust. So we don't want it during flight. We've got nice cold air outside. We certainly don't need it outside. Okay, 32. Air supply for the engine LP air starter motor can be supplied from, again, I did this one earlier. So where can we get some air for the air starter?
APU, ground.
Ground, yeah. And also
And engine, it is all
Engine only run.
another engine, yeah, another engine, good. That section up there is an APU via a pressure regulating valve. The regulating valve makes sure we don't have too much pressure of air going in, which could potentially damage. So we're regulated through a pressure valve to make sure we get the right pressure of air through there. Which type of starter is classed as a monofuel? Excuse me. So which type of starter is classed as a monofuel starter system?
IPN starter.
That's the one, yeah, IPN, isopropyl nitrate, the nasty stuff, the stuff that just keeps burning. Yeah, IPN. 34, the 3 elements that must be in place in the correct order as well for successful engine start are what? In correct order, what's the first one?
Rotation, fuel, ignition.
Good. Rotation first to get the air in, then we can add the fuel. Once we've added the fuel, then we can add the ignition. We can't do anything until we get rotation. Okay, rotation, fuel flow, and ignition. 35, the air for an air turbine starter can be obtained from, very similar to what I've had already.
Again, air can be obtained from APU.
Yeah, APU, ground supply, or another run engine. Yeah, just a follow on from the previous question. 6, what is the purpose of the safety resistors in a high energy ignition unit?
Protect the circuit in the event of fire.
Yeah, so inadvertent fire when there's an open circuit in effect. If there's no igniter fitted, the safety resistor will sense that and it'll just ground it away to earth, even if you press fire, because you've basically got an open circuit. So open circuit, okay, the resistance totally changed, and the safety resistor will sense that. So protect the circuit if it tries to fire with no igniter fitted. Before removing air gap type igniters from a gas turbine engine, what should you do? So what would you do first?
Gap of 3 minutes.
We trip the CB.
Yeah, electrical power first, yeah. So circuit breaker. You might gag that, you might put a label on it, say no power to be applied, that sort of thing. Then what would you disconnect after that?
Plug.
The igniter plug?
Yes.
You're dead. You're doing the funky chicken dance again. Yeah, before the plug. Which lead do you disconnect before?
LP. LT.
Always the LT. Think low power, low tension. LT, low tension, yeah. Low tension lead first. Then you will wait how long for an air gap igniter?
1 second.
1 second.
1
minute.
1 minute.
You're doing the funky chicken dance twice.
And 3 minutes.
3 minutes. 3 minutes, yeah. Yeah, 3 minutes for an air gap, 1 minute for a surface air gap. 1 minute for a surface gap, 3 minutes in this case for an air gap. Then you can disconnect your HT lead, and then you can disconnect your igniter, okay? Providing you're still alive. So yeah, minimum of 3 minutes must elapse between isolating your LT circuit and disconnecting your HT lead last. Okay, always in that order. Don't do it the wrong way around. 38. One of the requirements of the fire detection system is, could be lots of things, but the basic ones.
Fire what?
Just what's the fire detection system? Yeah, it should be fire resistant. Yeah, it should be able to detect fire. Yeah, I'll give you that one. The main thing is, though, it must distinguish between a fire condition and an overheat condition. Okay, so it's got two things. Just because it gets a bit hot in there, we don't want to let the pilot, oh, I've got a fire, but it's just an overheat, just a slight. Don't be wrong, if you've got an overheat condition, there's a chance that, well, that's not right either. That could be something else that can go into LP cooling duct, again through thermocouple and so on and so on. So you'd have to do a few things there. But you might have just a slight overheat condition where it's not a fire, you've just maybe let the engine overheat a little bit too much, you know. You can cool it down, but don't worry about that. So it must distinguish between an overheat and a fire condition. A thermal expansion switch consists of a steel barrel and the two contacts made from what type of material? Say again?
Inbar.
No, you're thinking another one. Not bimetallic, no. If you picture the steel barrel, inside there's two contacts which come together. Okay,
Silver.
so two contacts.
Silver radium contact?
No, silver rhodium. Silver rhodium contacts. Okay, the other type of switch you're thinking of is the Invar and steel. The thermal expansion switch is the silver rhodium. Okay. A single wire thermal expansion switch operates on what principle?
$28 DC volt.
Annual sensing. Or
Sort of.
Thermal switch low?
I'll maybe change the question. I'll put what power supply. I'll maybe change this question to that one. So single wire thermal expansion operates on standard AC. Okay, I'll change the question. I'll change the wording on that one. Okay. Differential expansion switch detector contains. What does it contain? This is the one you're thinking of. You see the background there. Differential expansion switch contains
Bimetallic strips.
This is the bimetallic one with the Invar steel, yeah, which expand and distort to break the contact and initiate alarm. Okay, so thermal expansion one is your rhodium contacts. The differential expansion one is your bimetallic strips of Invar and steel. Okay. So that's just the end of Book 2's revision. A few questions there. I'll change a couple of questions there actually, just to I've noted there myself. Okay, but how did you find that? Not too bad?
not too bad.
That's 2 books done. Another 2 books to go. We're halfway there, living on a prayer, as I say. Okay, for the last 10 minutes or so, I'll just randomly go through the book. Just recap anything else I might want to point out for Book 2. Then after lunch, we'll do some Book 1 revision, just to recap what we did at the start of the week. And then we'll see how time's doing, and we'll do a little bit of Book 3 possibly. We'll see how we get on. Okay. So I'll just look through some of the books here. Some of the parts that I may have not highlighted already. I'll just highlight that one. Okay, let's look at if we have used a fire extinguisher on an aircraft. What must we decide on how to cope with that? What are the 3 things? So treatment of a power plant after contamination of an extinguisher. What are the 3 things we need to check before we do any remedial action? What's one of the first things we need to find out? So extinguisher has been used in aircraft. What would you want to find out first? Yeah, it could be, yeah. Yeah. What else? So we're looking at the action after discharging a fire extinguisher into an engine will depend on 3 situations. So how we're going to clean this engine or maybe recover the engine will depend on 3 things. Oh, excuse me. Oh, bit nosy. So 3 things we'd have to find out first. Get some information about why the extinguishment was used. So I'll give you a clue. The first one is whether the aircraft was flying or the aircraft was on the ground. Okay, that can determine how we deal with what's happened with the engine. Okay? What's another bit of information you might need to find out?
Type of extinguisher.
Yeah, the type of extinguisher used, yeah. Because that determines how we clean it.
Whether the extinguisher into the engine or remain.
Yeah, where the extinguisher is going inside the engine or just round the side. Okay. Okay. If we're on the ground, somebody back in there, we can hear. We can use a dry powder extinguisher. That's fine. What happens if we use dry powder extinguisher on the outside of the engine? How do we clean it off? So dry powder, how do we clean dry powder that's been used on engine, on the ground, but it's outside the engine. So it's not internal, it's external. So how do we clean that dry powder off? And what do we definitely not use to clean it?
Vacuum cleaner. Vacuum cleaner.
Yeah, vacuum cleaner, yeah. Brush it off. You also be protect the equipment, you don't want to breathe it in. Brush some of it off, use a vacuum cleaner to get into the small parts so you can't get in the brush. What you definitely not use to clean it with?
Water.
Yeah, it'll become a sticky marshmallow. That's what it'll be like. Okay, good. If you have used a foam extinguisher on the engine, what can you do there? How would you clean the foam from an external engine?
By using water.
Yeah, no, you can use water. Foam's got water in it anyway, so you can rinse it off. And then if you want, instead of drip and drying, we can use an air gun in there just to dry things off. Again, make sure you've got PPE and a mask and all that good stuff on as well. If you're using CO2, what would you do? So a CO2 extinguisher is probably the standard one to
Ventilation.
Yeah, ventilation. Open the doors, let it ventilate. Give it a good, 20, 30 minutes, let it ventilate. Things you have to watch out for if you use a CO2 extinguisher. And to be honest, any extinguisher, because it's coming at high pressure fast and it's also quite cold. So what do you have to watch out for if you use, especially a CO2 extinguisher? What could that effect have on any hot parts of the engine? So you've got a big hot engine, you put your fire extinguisher on the access door, you squeeze it, and what potentially might have happened in the engine? Or not in the engine, outside, certainly hot pipes or cases or whatever. What could have happened between the hot and cold surfaces?
Clip.
Yeah, it could crack due to thermal shock. Yeah, you've got the CO2, it's coming out very, very cold under pressure. If it suddenly goes in a hot pipe or casing,
Crack.
so yeah, inspect the engine in cases of shock. Right. Which type of extinguishants are very corrosive to titanium?
Halon.
Halon. All right, good stuff. That's fine. Most of that stuff's quite straightforward, so that's not too bad again. We'll just double check the numbers. BCF is known as halon. What number? BCF, halon.
121.
Yeah, 1211 or 1211. BTM?
3010.
101. Yeah, 101. Yeah, good. All right. Okay, let's find out. Let's find out. Okay, there. Okay, when we're fitting firewire elements to the engine bay, we use the little clamps that clamp over. There's a little cam lock in there. How much of a turn do you put on those little locks? Is it full turn, half turn, or a quarter turn?
1/4 turn, quarter turn.
1/4 turn. The little clam locks, yeah? You only need a quarter of a turn, and that's in lock position. Again, they do vibrate out, so again, when you're inspecting firewire in an engine bay, make sure that actually fully. Don't spin them around, you'll just break them. All right, good. What is another name for a pneumatic type detectors? What's another name for pneumatic type detector? Sounds like something you might eat.
It's a doner.
Yeah, a system doner, not doner kebab, a system doner. Typical values when the sensor element is exposed to the heat in the range of, we've got 3 heat ranges over a certain distance for the pneumatic type detector. I'll give you the first one. It's 250 degrees C over the total length of the element. Then we've got 2 more temperature ranges. What's other temperature ranges? So 250 degrees over the total element.
380.
380 over any 5 foot, and 550 for any 1 foot. Yeah, I need to check that one actually, but yeah, we'll use that for a moment. Good. Okay, dokie, dokie, dokie. That's fine there. We've done those ones. Okay, power supply for a resistive type firewire, continuous loop type 1. What is the power supplies for it? What can we have? What's the voltages?
28.
Yeah, and maybe occasionally you might have most of the time it's 28 volts DC, but sometimes you can have a system that's fitted with
PMA. AC current.
AC. How much?
115.
Yeah, 115. Yeah. Occasionally you can have 115. Good. Okay. That one's okay there. Firewire detection units can generally be split down into 2 types of firewire detection units. What are they? So firewire generally split down into 2 types. They both start with the same name.
Continuous loop and continuous length.
Good, thank you. Continuous loop and continuous length. Good, good, good. That was that one. That's all good. Right, if I said to you we've got types of detectors, we've got unit type detectors and continuous detectors. Okay. Where would you fit a unit type detector?
This type?
So you've got unit type detectors and continuous detectors. Where would you fit a unit type detector? Say again, sir?
Thermal extinguisher.
Yeah, where there's a specific point where there's actually a good chance of a fire happening. So we call them point detectors, yeah? A specific point in the engine bay, like maybe zone 1, there's a good chance a fire might happen, or even the hot end, you know, the point detectors. And the continuous ones are like your firewire. We've got a loop of firewire which monitors the general heat going round. Okay. Okay. That's the other one's going to look there. Just let me highlight that one for you. Does anybody remember the weight of the aircraft where you don't need to have fire detection zone? Good, yeah. Good. Two types of igniter plugs. Which are, yeah, they got the superscript, good. Again, make sure, so you don't do the funky chicken dance, make sure you know the order of safety when you disconnect ignition system. So power, wait for, power, LT lead, wait for 1 minute for surface gap, wait for 3 minutes for an air gap, then you can go and work on your, disconnect your HT lead. Okay. Good. That's all fine there. How are we doing for time? Just about lunchtime. Quick on starter systems. Make sure we've got this right. A start requires what 3 things in the correct order?
Rotation.
Yeah.
And
yeah. Good. It must be in that order. RFI. Rotation, fuel, ignition. When or what we can use a starter motor in an engine to turn the engine without adding ignition or sometimes even fuel or ignition. What do we call that rotation of engine? What's the name we give it?
What is the question, sir?
We can rotate an engine without putting ignition on, and we can rotate an engine without putting ignition and fuel on. So what do we mean? What was the terminology we use for rotating an engine without fuel or ignition?
Hung start.
No, just in general. No, not a hung start. We're not trying to start the engine. We are just starting the engine, but we're not going to start it on purpose. We just want to rotate it. So what do we call that? Different name for it?
No idea.
No, we're not starting the engine. We're not adding fuel. We're not adding ignition at all. We're just going to turn the engine.
Dry motor.
Cranking. Yes?
Crank.
Engine cranking. They can use dry cranking and wet cranking. Dry cranking is turning the engine over with starter, no fuel, no ignition. Wet cranking is turning the engine over, no ignition, but with fuel. So the reason we would do that is we've maybe got a new engine. It's got inhibiting oil in there, which we'll cover in the next chapter. And we want to get rid of that inhibiting oil to put some fresh fuel in. An example of that is you put a new engine on your aircraft, you need to get rid of the inhibiting oil. So you'll do a wet crank. So you crank the engine over, you'll add fuel by opening the throttle, but you won't have ignition. You just want to flush out the inhibiting oil. Once you've done that, well, you've got a wet engine. So we don't like that for starting because that can cause big flames out the back end. So what will happen after that? You'll do a dry crank. So you rotate the engine, no ignition, and this time no fuel, and that will dry out the engine. Once you've done that, everyone's happy, then you can go for a normal engine start. And that's the standard procedure if you're fitting a new engine. Okay, but again, we'll cover a bit more on that later on. Okay, that's there. That's done. How are we doing? Right, I think that's just about time. Any questions you want to go through on module 2, book 2 at all before we go for lunch?
No.
So that's just some general questions there. If you have any questions about book 2, let us know after lunch. If not, we